Well, good morning. What we have here is part 3 of the auction score. What you can see down here are two 4335A synthesized level generators. Above that is an E. Up here, this guy is an E4406A Vector Signal Analyzer, and then over on the side here, which, if we move the little light, you'll see this is an E8285A CDMA Mobile Station Test Set. Now, I didn't really want this guy, but to get the Vector Signal Analyzer, I had to get the CDMA Test Set as well. But people say that it can be used as a service meter or a service set for radios. So I want to do a little bit of 900 megahertz stuff, so maybe that will be useful to me. We'll take a look at it in detail anyway. So here, the reason that I wanted the 335As is these are very, very accurate level generators. So they will have something in the range, if they're still calibrated and accurate, they'll have a level that's flat and be able to be accurate below 40 megahertz at something like 0.02 dB, or above that it's something like 0.05. They're very, very accurate once it's all tuned in. So I wanted to get those so that I could have an accurate signal to do some of the other calibration work that I've been doing with my other gear. Didn't need two of them, but that is what it is. The Vector Signal Analyzer is basically an FFT spectrum analyzer, so it partners with some Keysight software there. I think it's the 89600 or the 86900 series, and so you can get actually quite a bit of detailed information about that. Now, for that protocol, that work in the 900 megahertz stuff, I was going to decode some protocols from some wireless sensors, and so I'm hoping that I can utilize this piece of gear to look at the signal and then work out what the protocol is from the signal that's coming out, and so that we should be able to feed that in. Anyway, these units are all plugged in, ready to be turned on, so let's start from the bottom. We'll start here and we'll work our way up and we'll see what happens. Okay, so for the first thing for us to do is to power them on. So okay, well, the bottom one doesn't seem to want to turn on. And there is a dramatic lack of lights on these guys. You can see unlocked being lit there, but nothing else is turning on. Now, when let's turn that off. When I checked, these things were, the calibration stickers were still on the backs of them, so they hadn't been opened, but they might have actually just failed and then been whacked on a shelf. Okay, let's try the next unit. Okay, so let's at least we have a standby light on this guy, so let's turn him on. Oh, there we go. I was starting to get worried that maybe it wasn't going to boot. This is, I believe, a Linux-based system, and so you can get into the actual boot sequence. I don't know what the actual startup screen is supposed to look like on this, so I'm not sure if we've finished actually booting up or not. So let's keep it going. Oh, no, clearly haven't continued to boot up. Arcturus, nice. This is a morning, so drink of choice is a Bloody Mary. Nice. Looks like we passed all the self-tests. Okay. Now, I haven't read the manual on this at all. I just saw it become available. So we'll have to see whether or not I can work it. Let's hook up a signal and see what happens. Okay. So I have my 8657B hooked up now with a 1 gigahertz signal. So let's 0 dBm. Let's turn that that on. Nice. We can see that the items here. Let's see if I can get a marker measure. No, hang on. Amplitude. Is there a marker? Marker, there we go. Now 16 dB down, minus 16 dB. That doesn't seem right, but then again I may not actually be using the system correctly, because it should be 0 dBm out, and this cable's not a well, this cable shouldn't be at 1 gigahertz, shouldn't be losing that. Let me step that down a bit to say and frequency, center frequency, will make that 100 megahertz. Okay, frequency. There we go, 100 megahertz. We can see our item there. Let's expand. It's 1 megahertz. So let's take the let's expand. Let's make it 1 megahertz. All right, so let's take that marker again. Alright, so that's minus 15 dBm. That's got to be something that I've set up, that's set up in here. So I'll need to go actually read the menu on that. But let's just go and see what. Let's have a look at the waveform. Okay, I don't know what that's done. Channel power. Yeah. Oh, alignment needed, it says. Okay, anyway, there's at least some stuff that's working. Let me turn this RF signal off. Okay, and then do a preset on this. We'll do system. Show any errors. So signal in noise floor, power actually degraded, alignment needed, data out of range. So I don't know when those occur because it didn't give me. Let's clear that. Okay, so now. And a marker, and I bet you it's still at minus 16 dBm there. Yeah, I'll take a look at that. So, it's got to be something that that I'm doing, hopefully, and not an attenuator issue with the unit. All right, let's move on to the next one. Okay, so we're going to try the CDMA test station now. I really know very little about it, so we're just going to poke some buttons and and see what happens. I read a couple of web pages on some things, so we'll see what goes on. So I know, you know, when I say I know nothing but the operation of it. I know a few bits of data that I read off the web page. There's apparently 2 or earlier versions of this stuff, and I think, you know, because we see the bootloader being a B revision, what they were saying was that the earlier firmware lets you go right down to you know, about 100 kilohertz or something utilizing this unit, but after some point in time, Agilent, because when they were making it, just decided that they didn't need to do the calibration test on the attenuators below 800 megahertz, because 800 megahertz was the bottom of the CDMA or the mobile phone, the cellular phone bands. And so they didn't put any of the calibration data, and the firmware actually stops you from going below that. Now, you know, I have a bunch of gear here, so you never know. I might actually be able to do that calibration myself. So, oh yeah. Now, I'm guessing that because it does CDMA and it does analog, we really want analog. So let's go, excuse me, let's go and set transmit, I think. So now if we look at it, the electroluminescent display is pretty cool. I think we can go in and say change this. Now by default, it's, you know, because it's designed for radios, and it's reading in a channel effectively. And so I think if we scroll through, you know, we can change the different types of channels, and, you know, so that it will actually jump appropriately between that. But, you know, I'm not doing CDMA, so I want that to be in megahertz. So let's see what we can do in config. And the date, let's see, July 9th, 29. Clearly the battery has died in this at some point. Display user message, yep, time-based. Oh, there we go, RF channel. So let's move this guy down here, and yep. So do I want general? I don't know if I want an RF off, so I don't even know what that is, but at least we got it back here. So let's go back to our transmit test, and now let's let me put my RF generator on, and this is just my 8657B again. There we go. Now this cable has about a 1 dB loss at 1 gigahertz. So at 0 dBm I should be reading anywhere. I think from memory I'm about minus 0.25 at dBm below 0, dB below 0. So as long as I'm reading about minus 1.25 at a gigahertz, I should be about right. So I've got it set for 900. So let's go and type in, well, let's come back up here. Well, here, let me go back up here, and here we'll type in 900 and hit megahertz. Okay, let me turn on my RF output. And you're seeing that we're getting this. Now, I don't know if I particularly want that. So let's see if I can change it from frequency error to frequency. There we go. Now, this thing hasn't warmed up, so it'll have its own, you know, internal frequency reference. My signal generator is running off a GPSDO, so it should be very close to 10 meg. Now, oh, okay, so the input port is antenna. This thing has an integrated antenna in here, so I can come in and say I want, there we go. Now we're reading better. Okay, so let's go up here. Let's change that. That should be able to change to dBm. Oh, nice. So we're at minus 1.21 dBm. Okay. Now let me just change my amplitude here to say minus 10 dBm. And we see the good. So that seems to be, amplitude-wise, seems to be working. Let me whack in a little bit of FM now. So we'll put 5 kilohertz of FM deviation in at 400 hertz. And that's what we're seeing. We're seeing about 5 and about 400 hertz. There, let me change that now to a kilohertz. We should see that change. There we go, nice. So this seems to be working reasonably well. Let's go back and see what I can do if my suspicion about the minimum frequency here. Yeah, see, this is obviously in the lower ones. They went and they said, well, you can't go any lower than 800 megahertz. So I wonder what the 1000 gigahertz. No, because this will have still have the ranges. So I think the next range up is like 1800 megahertz. There we go. You know, and so now we can go up. So if we go, you know, to 1818, and I'll change my frequency of this. You know, and there we go. We're, you know, a little bit of extra loss in the cable now. But we're still reading okay. So, yeah, overall, you know, not. So let's see what spectrum analyzer do. Oh, there you go. That is actually what the sort of spectrum span I would expect. You know, so let's see if we can change that span. I don't want to do that. I want to come back. I didn't mean to press that. Cancel. There we go. This actually has iBasic in it as well, so it can be a controller. Here we go, the span. Let's do 50 kilohertz on that span. That's a classic FM deviation there. You know, let's switch that over to AM. Turn the FM off. Turn the AM on. Put it at 1 kilohertz. And we'll take, you know, say 20%. Let's change that span now to 20 kilohertz. And there you can see the two sidebands appear from the AM for the amplitude modulation. Alright, well, so that's pretty cool. It's an audio frequency analyzer, I guess. FM deviation. SAT deviation, no idea what that is. Okay. I wonder if it does analog. No, I don't really know what I'm doing now, but you know, we're still seeing, you know, yeah, let's go back to, yeah, it's going to turn the volume up. No. Alright, interesting. Well, that still seems to be doing a reasonable amount of testing. So I'm assuming that you could do a device under test usage with this as well. Let me turn that RF off there. You know, you could do a device under test version of this by switching over to the RX test, and then feed in, like from here, set it at a particular signal level, you know, what you want, what the signal you're going to generate in, and then bring that back into the unit and see what the distortion and so on is going to be. So anyway, that seems to be working. The E4406A seems to be working, and I think we've got an interesting repair video done for, will come up for the 3335As, which I'll have to do when I get back from vacation. Anyway, we have I have one more item in the auction score, but I'm not going to be able to get to it because I think I need to buy a couple of little probes for it to make it work. But we'll do that as a separate one, and that's an 8405A Vector Voltmeter, which I bought because it's just cool. I got it for like 20 bucks. Nobody else wanted it. So I was like, you know, it's just a cool thing. I don't know if I'll ever use it, but I thought it'd be cool for us to take a look at. Anyway, I hope you found that interesting, and I'll catch you again later. Bye.